I killed my Monstera for months. And the stupid part? I genuinely thought I was taking care of it. My first expensive Monstera cost me nearly $200. It started drooping, so I watered it. Then the leaves turned yellow, so I fertilized it. Then the growth slowed down, so I watered it again. Within months, that plant was barely hanging on. And I kept treating the leaves. I didn't realize the real problem was underneath them. I wasn't starving it, I was suffocating its roots. That mistake completely changed how I think about plant care. Because a plant can sit in visibly wet soil while its roots are biologically starving, not for water, for oxygen. Roots aren't just drinking straws. They're living, respiring tissue. They need oxygen to generate the energy required to power active transport, maintain cellular function, and absorb nutrients. Think of the root zone like an underground power grid. Water is the supply line. Oxygen is the electricity. Remove the electricity, and suddenly the system can't run properly, even if the supply line is completely full. That's what happens when substrate stays saturated. Water occupies the pore spaces where air normally moves. Oxygen diffusion becomes dramatically slower. Root respiration drops. Energy production suffers. And nutrient uptake can become impaired. That's the trap. You see a drooping plant sitting in wet soil. Your brain says it's thirsty. But the roots may be sitting in an environment where they can't breathe properly. And this is where I completely misunderstood what was happening with my Monstera. The root system isn't operating alone. It's surrounded by the rhizosphere, the microscopic zone where roots, minerals, water, and microorganisms interact. Think of it as the plant's underground neighborhood. Roots release compounds called root exudates. They're biochemical messages released into the surrounding substrate. They influence microbial activity around the root surface and help shape the biological environment surrounding the plant. But change that environment dramatically with prolonged saturation, and the biological balance can shift. And now we reach the part I wish I'd understood months earlier. Low oxygen conditions can weaken root function and create conditions that are more favorable to certain root disease problems, including Oomycete pathogens such as Pythium and Phytophthora. That doesn't mean wet soil automatically equals disease. It means chronically stressed, oxygen-poor roots can become a much easier target. And once significant root tissue is lost, the leaves upstairs can start sending some seriously confusing signals. This is where conventional plant care can screw you over. Water every Sunday, fertilize every 2 weeks, mist the leaves, follow the schedule. It sounds organized, but plants don't live on calendars. They respond to biological conditions. A plant in a breathable substrate under high evaporative demand is not experiencing the same root environment as that same plant sitting in saturated soil in a cool corner. Yet the schedule treats them like they're identical. That's the problem. And I made it worse by treating symptoms. Yellow leaf, more fertilizer. Drooping, more water. Slow growth, more inputs. I was adding more resources to a system that couldn't properly process them. It was like pouring gasoline into a car with a dead engine. So I stopped asking, what does this plant need? And started asking, what is preventing this plant from using what it already has? That question changed everything. Module 1. Measure the root zone. Stop watering on a calendar. Don't judge moisture from the top centimeter of substrate. Use a high-accuracy moisture meter to check deeper into the container, while also physically inspecting the substrate when appropriate. You're trying to understand the environment around the actual root mass, because the surface can look dry while the lower root zone is still saturated. Module 2. Engineer the physical structure. If the mix collapses into a dense, muddy mass, you've got a physical problem. For many tropical collector plants, I want a structure that maintains moisture while preserving meaningful air-filled pore space. A practical chunky mix can start around 40% orchid bark, 30% pumice, 20% lava rock, and 10% horticultural charcoal. The exact ratio isn't sacred. Species, pot size, climate, root density, and watering frequency all matter. The principle is what matters. Don't build a substrate that stores water by eliminating the air. Build one that holds moisture while preserving pore space. Pumice provides durable mineral structure. Lava rock adds coarse, stable pore architecture. Bark contributes organic structure and moisture retention. Charcoal adds additional surface area, but it isn't some magical microbial cure. You're engineering a root environment, not following a potting recipe like it's law. Module 3. Inspect the roots. If the plant keeps declining despite reasonable surface care, inspect the roots. Look for structural integrity. Look for tissue that is collapsing, mushy, or clearly deteriorating. And if you see signs consistent with root disease, don't just dump fertilizer into the container and hope. Remember Pythium and Phytophthora. Those pathogens aren't problems you solve by simply feeding the plant harder. Correct the environmental conditions first. Remove compromised material where appropriate, improve drainage and aeration, and prevent the root zone from remaining chronically saturated. Module 4. Control the wet to dry cycle. Don't chase maximum dryness, and don't chase maximum moisture. The target is a controlled moisture cycle, appropriate to the species. Water thoroughly when the plant actually needs it. Then allow the substrate to re-establish oxygenated pore space before repeating the cycle. The goal isn't less water. It's better root zone physics. That's the distinction I completely missed for months. And here's the frustrating part. That damaged Monstera leaf never recovered. I had to stop using the old leaves as my success meter. Instead, I watched what happened next. New roots, new growth, stronger leaves, more stable hydration, better recovery after watering. Those were the signals that the underground system was functioning again. I thought I was killing my plant because I didn't water it correctly. The truth was more complicated. I kept reacting to visible symptoms without understanding the invisible system producing them. Water, oxygen, root respiration, microbial interactions, pathogen pressure, vascular transport, they're all connected. Once you start treating the root zone as a biological system instead of a bucket of dirt, plant care becomes a completely different game. So now I'm curious, what's the first symptom your plant shows when something goes wrong? Drooping, yellowing, brown edges, or completely stalled growth? Drop the symptom you see most often. Because the next mystery is even stranger.